Air shear sprayers are used in agriculture to effectively apply chemical pesticide products. The use of air shear to disperse product requires less water to accomplish the application, creating a more efficient process, minimizing product waste, and providing cost savings. When sprayers are used without regular calibration, you risk over or under applying chemical pesticide products, which can lead to problems such as low yields, damaged foliage, soil contamination, and even pesticide-resistant insects and weeds. With this simple worksheet, you'll be able to see to it that your air shear sprayer is functioning as it should and in a cost-effective manner. These are also valuable records that can be used each season to track expenses, as well as the effectiveness of a given sprayer or application program. Like most calibration procedures, we'll measure a small sample in order to determine the total output over your entire farm acreage. First, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information along with the date, operator, location, and equipment being used for the calibration. Take note of the tractor's details, such as the tractor make and model, tractor tires brand, the gear it's being driven in, as well as the RPM. Also, record the tractor tire size and height from the ground to top of tire, and remember to record the sprayer make and model, tank size, and pump pressure. The tractor should be pulling a clean sprayer tank filled halfway to represent an average weight load. Next, we need to determine the speed at which the tractor is traveling. Because the calculations are based on a sample-sized plot of your fields, you'll be traveling a measured course, preferably a level, straight stretch, with conditions similar to the fields targeted for spraying. Knowing that the further distance you travel, the more accurate your measurement will be, it is recommended to travel a course of at least 200 feet in length. For this test, the distance is measured at 176 feet. Measure and mark the distance, and then use assistance to record the time it takes to travel the course, once down and once back. Record it twice, then average the 2 times in order to establish a standard time. If the first 2 measured times have more than a 10% differential, it may be necessary to repeat the timing tests. In this test, the time was 38 seconds for the first run and 38.6 seconds in the second run. We total the 2 times and then divide by 2 for an average run time of 38.3 seconds. Next, we'll convert the recorded times into miles per hour and speed per minute as part of determining how many feet per minute are being covered, and consequently, how much product is being applied at each foot. Calculate the distance in feet multiplied by 60, which comes to 10,560. Then divide that number by the time in seconds multiplied by 88, which we determined to be 3,370. This will give you your speed in miles per hour, which in this test is 3.13 miles per hour. Then, multiply the miles per hour number by 88 to arrive at the feet per minute being covered by the tractor and sprayer. This comes to 275 feet per minute in our test. Next, we'll determine the amount of time it will take to spray the targeted field. First, we'll measure the row width of the crop. Each calibration needs to be based on the specifics of the crop and growth stage in the targeted area. In this test, the sweet corn block is 53.4 feet wide, and both sides are sprayed. Therefore, the spray swath width is 26.7 feet. We know that there are 43,560 square feet in an acre. By dividing that number by the 26.7 feet of width in each row, we find that there is 1,631 linear feet per acre. Now, we'll divide the linear foot measurement of 1,631 by the speed at which our equipment has been measured to travel, which is 275 feet per minute, and we find that it takes 5.9 minutes to cover each acre. Now we know how long it will take to completely apply product to the coverage area. Next, we'll determine the amount of product that is being applied. First, fill the sprayer tank with water to a level that will allow for continuous spraying for the test time to be measured. In determining the amount of water sprayed, we will fill the tank to a given level and record that amount. With the tractor in a stationary position, set the same engine RPM used in the timing run. Set the application pressure that you normally use and spray water through the air shear. Spray for the amount of time determined in the test run, which for this calibration will be 10 minutes. At the end of the 10 minutes, we refill the sprayer to the point it was before spraying, carefully measuring the amount of water it takes to fill the sprayer back to the original starting point. Then, record the number of gallons it takes. For this example, the measured amount of output was 54.5 gallons. Repeat the process 3 times in order to determine an accurate average spray output. The second test recorded 55 gallons sprayed, and the third test, 54 gallons. Determine the average output of the 3 test sprays. With a total spray time of 30 minutes and a total output of 163.5 gallons, we'll divide each of those figures by 3 and determine that the average test spray for 10 minutes produces 54.5 gallons. The amount sprayed during the measured time can be then translated to the number of gallons per minute being applied. Divide the 54.5 gallons by the 10 minutes, which calculates to 5.45 gallons per minute. We then multiply the 5.45 gallons per minute by the 5.9 minutes per acre to determine that we are applying 32.2 gallons per acre. Remember that each application should be directly tailored to the crop and its specific stage of growth. One calibration will not be sufficient for applications during an entire growing season. Always read and follow label directions for any product that will be applied. Properly calibrated equipment will yield the best results and help keep you compliant with pesticide regulations. Knowing with certainty the amount of product being applied is the best tool for keeping your facility running productively and cost-effectively.